Given an array of distinct integers, candidates, and a target integer, target, return a list of all unique combinations of candidates with a chosen number summed to target. You may return the combination in any order. The same numbers may be chosen from candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. So all this means is that we have some target number and some list of numbers, and we want to use this list of numbers to add up to our target value, and we want to find all possible combinations that add up to our target value, and we can repeat on this. So for example, 7, we can use 2 twice and then 3 to get to that 7 value. We can also just use 7 by itself, and that would be an answer we need to include. So finding every combination from a target value based on a combination of given integers might seem daunting, but we'll find that this is just as complex as climbing stairs. In our climbing stairs problem, we said that we can either use a 1-step or a 2-step to get our next answer. And in all cases, we're using previous answers to build up to a new answer. Again, this is called bottom-up dynamic programming. We're going to visualize this slightly differently for combination sum. First, our candidates were 2, 3, 6, 7, and our target that we're trying to get to is 7. And with bottom-up dynamic programming, we're going to build smaller answers to get our larger answers. So let me just write something out. 2, 3, 4, 5, 6, 7. And with this, we're going to say 2, 3, 6, 7. And remember, again, the only thing that we really care about is this 7 answer, but we need to use smaller answers to get to this answer. And what exactly did we do here? We're just setting up our base cases. So we know that from 2 to 7, the only answers that we have right now are our trivial ones. So 2 is obviously going to be a combination of 2, 3 is obviously going to be a combination of 3, and so on. So here is where the magic comes in, and here is where this problem is going to be similar to climbing stairs. So for each one of our answers, what we're going to do is we're going to look at our candidates, and for each candidate, we're just going to add that number to here if it exists within our array. This will make more sense as we go through it. So let's look at our first example of 2. So for 2, we're going to look at 2, and we're going to say this 2 plus this 2. So we're going to go here, and we're going to say because this 4 exists within our array, we're just going to take our previous answer. So this 2 right here is 2, and then we're just going to add this 2. Next, we're going to look at this 3 and then this 2. And we're going to say 2 plus 3 is going to give us 5. So we're going to add this 2 and this 3 to this array. We're going to do the 6. So 2 plus 6 is 8. And because that is outside of our array, we're just going to stop. And then once we're done with that, we're just going to move to our next value. So this 3. So before I do this one, let's just change the color of it real quick. Let's say 3, and 2 plus 3 is going to give us this 5 value. So what we're going to say is 3, so this value here, and 2, this value here, to get another one of our answers. Then we move on to 3. We say 3 plus 3 equals 6. So we're going to get this 3 from here, and we're going to get this 3 from here. And then we move on to our 6, and we say 3 plus 6 gets us 9, which is outside, so we're just going to stop. So we continue in this way until we get to our 7 using these values every time. And once we get to the end, we can just return this answer with whatever else is in here. One thing that's important to point out though is right here. So we have this 2, 3 and this 3, 2. We got these from 2 different ways, but each one of these is the same answer. If we rearrange these, we get the same answer. So this is a duplicate. We can't have that. So when we're coding up our solution, we need to figure out a way to account for these values. And one last thing before we move on. So for our example, we always looked forward adding each one of these up. The way that I'm going to program this, I'm going to do it in the opposite way. We're still going to start with looking at these and then using our candidates. But what we're going to do instead is we're going to go to each one of our numbers in our dictionary. So once we get to 4, we're going to look at our 2, and we're just going to say 4 minus 2. We're going to look back, get to our 2, and then use this value added with this value to get our answer here. It's the same idea, just implemented slightly differently. So let's start coding our solution. First, we want to start off with our base cases, the small cases that builds up into our larger cases. So first, let's just say DP for dynamic programming equals default dix list. And again, all this is just a dictionary initialized with lists in them. So if I said something like print DP of 1, turn nothing just because we need to have something or this program will crash, run. We see that for DP1, we're just getting an empty list. We didn't actually put anything in here. With default dix, if you just ask for something that doesn't exist already, it'll just give it to you. So if I did something like this, where it's dp1.append hello, then prints dp, it'll put hello in there without us having to first make the array and all of that. So let's initialize our base cases. So L in candidates, dp of our elements.append element. Let's just print this out. And you can see that each one of our elements are being initialized, same as how we were first doing it in our picture example. Let's start building out the rest of our array. So let's say for I in range target +1. And all this means is we're going to go through each one of our elements in our dictionary from 0 to our target value. We need to have target +1 because if we didn't, we wouldn't include target in our range. So for C in candidates, this just means we're going to iterate through each one of our candidates elements. So again, we're going through each one of our values in our DP dictionary. And then for each one of those values in our DP dictionary, we're going to look at each one of our candidates. And what are we going to do? We're going to say if I minus C is greater than or equal to 0. So looking back, if we are in our range, we're going to add a new answer to our current element in the DP dictionary. So one thing that I had forgotten to mention was we need to add all of the values from a previous element to our current element. So take this, for example. We know that for 6, there are 2 different ways of getting here. Suppose we had a 1. Suppose we had just like some 1 value. Like that. Then we'd add this 1 to all of these elements here. So we'd say 6, 1, and then we'd also add this 1 to this 3 element here. So 3, 3, 1. So how do we do that? First, let's get those values. So for, let's just say combination in DP I minus C. So this will get us all of those combinations to make up that smaller answer. And then we can say DP of I dot append combination plus C. And let's just see what this looks like. So you can see here for 6, we get 2, 2, 2, 3, 3. And for 7, we get 3, 2, 2, 2, 3, 2, 2, 2, 3. So it looks like this is working, but we still have the issue of the duplicates. And also just to emphasize on this, combination is a Python list. And in Python, we can add Python list to a Python list. And all this really means is what we were doing before. We're just appending one list to another. So if we had something like, we would just combine these together to get this. Let's figure out how to get rid of the duplicates. And for this, we're just going to create a different function. We're going to call it def already in, and what do we need to pass? Some array answer list. So let's say something like for element in answer list, if array equals element, turn true, turn false. If our considered element is the same as whatever's already in our list, then we return true to say we're already in it. But if we had something like, and this wouldn't be the same. So how do we make it be the same? What we're going to do is we're just going to say array.sort. Every time we put a new element into our answer array, we need to sort it first. So instead of just saying like combination or something like that, let's do something like temp equals combination plus C, and then do temp.sort. We'll check to see if it's already in there. So if already in, let's just pass temp and our current answer. So DPI, if it's already in there, we're just going to say continue, which just means skip. So we're going to go back to the beginning of the loop. Else, we're just going to add it in there, and we want to add in temp because we want to keep this sorted in there. We actually probably won't even need this array.sort just because we're sorting it before we put it in. So let's just get rid of that. And I think that looks fine. So let's just get rid of that. Let's do return DP of target run. Looks like we got accepted. Let's hit submit. And it looks like we are good. So let's talk about runtime for this solution. This will run in O of candidates times targets. So we can say O of m by n, which in the worst case could be pretty much O of n squared. And why are we allowed to do that in this case? It's because if we look at the length of our candidates, as well as the size of our target, the numbers are low enough such that an O of n squared would be accepted. And that's it. If this video helps, please consider like, subscribe, and I'll see you in the next one.